now the class is being recorded, okay? Only on the desktops. Don't worry, you don't have to be like, oh my god, my face is on the camera. There's no camera, okay? It's literally just what's underneath this camera here and my laptop, okay? Whatever you see on the desktop, pretty much whatever you see on the screen is going to be what's going to be recorded, okay? I think additionally, I have this to bring up. Mr. Weebly. All right, so give me a few minutes to kind of get that going here. Internet's been a little bit slow for me. Fill the screen. Come on, Mr. Wee. Okay. Okay, so one note before I start today. So today we're going to be going over, prepare for going over sections 1-1 to 1-7. We're going to get through like 7 sections today. I saw Natalie's face like, what, dude? That's crazy. Okay, maybe not. I don't think that's what you meant, actually. But we're going to get through about 7 sections today. They're actually pretty fast, pretty quick. If we have time, we might get to graphing calculators. Raise your hand if you've already checked out a graphing calculator. Okay. Raise your hand if you don't have a graphing calculator at all right now. Okay, so definitely find a way to check it out or consider purchasing one that's used, okay? I would never suggest buying it new unless you have to. But if you can, convince your parents to get it used and save a lot of money. It's the same technology I've been using since like high school, since I was in high school. Does anybody know how long ago that was? Oh, not long ago. Okay, I was expecting to be offended. Like 30 years ago. Old timer. Okay, I guess it's not that long ago, but it was about 15 years ago that I was in high school. So, and I still use the same one I have. In fact, one of my personal ones and my girlfriend's personal ones are literally in that box, okay? They're the same exact calculators, and yet they're charging you guys the same price I paid for back then. Even about, well, actually, with inflation, it's like $10 to $20 more. So kind of get that through your head. Someone's making money here, and you know, because you guys got iPhones that are like 100 times more advanced than any of these. But anyways, I'm getting ahead of myself. I'm getting cranky, guys. I'm getting old and cranky. Okay. All right. So one note of caution. Fayad actually brought this up. These dimensional analysis worksheets. Okay, they're a little tough. So in case you haven't noticed, I have the solutions now updated. These are actually updated solutions. Some of you guys were like, these aren't the solutions to the actual worksheets, Mr. Wee. These have been updated last week, and I've been putting up tutorial videos. Bear in mind that I like to talk a lot, okay? So some of these tutorial videos are like 10 minutes long, so you might want to kind of fast forward, or if you have a cool app, you might want to have a speed up option, okay? So sometimes I speed up lectures like 2 times as quick to get through them, okay? Yes? No, it's the same. It's the same exact sheet. So Ivory brought up a good point. If you open up this worksheet, part 1, and then you open up part 2, okay, that's where you might begin to question how old is Mr. Wee, because he is going senile. It's the same thing, okay? I know it is. I'm just kind of letting you know. Maybe I should have just made that one line. That would have been a little bit smarter, huh? At the very end, there are 2 parts. This is what I meant. Part 1, you have to do, and then this part. Yeah, please don't print out 2, and then that's not what I'm trying to imply. And I'm sorry, I'm sending you mixed messages, and I shouldn't have been doing that. Okay, so just print out 1, and then this is part 1, this is part 2. Does everybody understand that? Okay. Yeah. Did you have a question? Okay, no, you're just like, yep, number one. Okay. Without further ado, let's go ahead and begin our work for today. So kind of get ready now. I have a new location for my markers. Actually, Malvin, can you help me out? Can you bring out that bucket right there? That bucket, and then put it on, let's see, what's a safe location? Actually, just put it straight onto that cart right there. Yeah, just right onto that cart so everyone has easy access. For now on, the bucket of markers and erasers are going to be over there, okay? Leave them spread out. It's fine. Just leave them visible. Don't hide it in other places, okay? But be prepared because we're going to do some board activity right now, okay? So kind of get your feet warmed up right now, all right? All right, so here's your warm-up. It's going to be multiple problems. You and a partner are going to work on this. So just find any partner, okay? Just get close and comfy, not too comfy, all right? All right, back up. Give me my space, okay? All right, so I have these questions. Let's see how many of you guys can get these right. You guys can already go up to the board or go find a space on the board. Go get your markers. As I'm writing this up, I want you guys to solve all these problems. There's going to be about 6 problems for you guys. There's a little warm me up. You got to warm yourself up. Okay, let me back up a second so I don't have you guys tripping over me. Yes, you can. Anything on the board, erase it. If there's anything on the board, erase it. There are multiple whiteboards all over the place, okay? One next to Fayad. Who's next to you? Who's next to Fayad? What's your name? Hassan? Hassan? Okay. So there's the boards next to Hassan. There's boards next to Malvin. What's your name, miss? Kylie. There's one next to you, Kylie. You can grab it, whatever. Huh? Oh, sorry. Thank you. Sorry about that. Yes. Huh? That's a multiplication dot. Sorry. Yeah. That's not a hair. That's nothing else. I'm sorry about that. Throw away any bad markers. So if you guys have any bad markers, just throw them away. Okay. Okay. Trash can's right there, Katrina. It's right there. Okay. That's okay. I'm just kidding. All right. It's fine. All right. Yes. Yes, the number's in the front. 3 and 3 only. Yeah, you cannot multiply the number inside the square root sign. Just join the team, Tessa. All right? Just join a team, okay? Please grab any whiteboards. There's a whiteboard actually. Ma'am, what's your name? Miss. No, yeah, you guys. What's your names? Sierra and Marwa. Am I saying that right? Marwa. Okay, guys, there's also a whiteboard between Marwa and Natalie as well. Grab any whiteboard you guys find, okay? There's a personal whiteboard right there. You guys can grab it and bring it to your desk. Okay, you have 7 problems. These are your 7 problems that you must do. If you don't know how to do it, look at other people's work. This is not a test. Just be like, how do they do it? How do they do it? Okay, don't be ashamed. Look around. Okay, this is literally how you help out other people. Not by cheating, but by just looking at other people like, hey, that's influential. That might help me. Okay? And if you don't have room for the last 2, number 6 and number 7, you can go back to your desk and work on a paper if you want for the last one. Okay, I'm going to walk around, and then I'm going to help you guys if anyone needs help.
It doesn't matter. Now I gotta go 15 meters. So how many?
3.28. So it's over inches or inches.
So like if they were in the same line,
So you gotta use it like counting each direct foot.
so just no, it is.
Well, there you go. Exactly. And you can cancel out that.
Yeah, 200 meters over
Yes.
39.
There you go. That's it.
39.3.
You don't have to do math. Oh, that's it. I asked for me. Sorry. Don't worry about mine. Oh! Sorry. Let me write down some facts that might use. That one's hot. Sorry. You're on the last one. I didn't know that.
Okay, so 5.1.
Okay, I'm gonna give you guys about 3 more minutes to solve everything. Everything.
Look at this paper. You want it on the bottom? No, I need a paper.
In 2 miles per hour.
Not here. You're gonna learn what's called dimensional analysis. So take this and then do the video.
So like now you have to
Good to see you, Brendan. Okay, 2 more minutes. I'm gonna stop you. Yeah, you do not have to do level 2. The pink. That's just optional.
Inches to feet.
I love this discourse. People are well. You don't have to insult other people. It's not hard for me. Okay, don't do that. Right? But just be nice to each other. Right? But you can debate. You can debate answers. Right? 1 more minuto. Uno más, guys. Uno más. Who can get to the end?
Are you sure? Because it's 528 inches per second. That has to be wrong. That has to be wrong. Okay, so wait. So let's do this.
That's 528.
5 per second. 28 inches. No, this would be 1 hour. You're right.
Oh, I didn't understand. How do you guys get 30 miles an hour?
Okay, so there's 5,280 times 12.
I used that.
Okay.
Very true. They did the work.
Okay, so you can cross out the seconds. And the hour. How many seconds are I thinking?
16? No.
We haven't done it.
3600 seconds. Oh, with that one. To be fair, he did also look around.
Yes.
Did I do something wrong? How do I do this?
Oh, looks good. Everything looks good. Why are you so scared?
Because Dash got something else, so I think that I.
Oh, the almighty Dash can't be wrong, can he? Oh, okay. Alright. Hello, Sophia. Yeah. Join in, we're just doing a warm-up, so these are the problems, and we're about to go over in like 2 seconds.
Oh, yeah.
Okay, in 10 seconds, please return to your desk and bask in the glory of your work. 5, 4, 3, 2, 1. All right, just return to your desk. Don't worry, I'm not going to punish you or anything, but just return to your desk, please. That's all I'm asking. Okay?
You're on the last one.
All right, are you guys ready to check your answers? Okay, the only two I left the last two blank. Okay, so you guys can check your answer. Check my answers too, in case I made any mistakes. But the first one, well, what's the name of the property that you had to use to get to distribute the distributive property? Okay, on the number 2, you guys might have learned it many ways, but I think of it as kind of like the distributive property times 2. You just distribute the x into every guy in here, so you should get x squared plus 3x, x times x, and x and 3. That's 3x, x squared and 3x. That's my technique. And then in pink, I took the other number and I distributed the 4 to those two numbers. Okay? If you can't remember a way to do it, just simply multiply this guy to everything in here, and multiply this guy to everything in here, and you're gold. Okay? Does that make sense? I combined like terms, so I should have gotten x squared, 3x, and 4x are the only like terms I can combine. So that's 7x plus 12. Any questions on number 2? Okay, how about number 3? Sorry, number 3 is over here. How come I did not multiply the 3 and the 5? How come I didn't do that?
Because they're not like terms.
They're not really not like terms. Once you're underneath this umbrella, I call it my umbrella, okay? You cannot touch it. You cannot touch that number unless you're multiplying it to another number under a square root umbrella. Trivia question, can I do this? And now this is equal to root 6. Is that possible?
Yes.
Okay. Yeah, if it's a cube root and a square root, these are not technically like terms, okay? But Malvin, I know there's other ways you can kind of finagle this, but no. For the time being, no, you cannot do that, okay? So they have to be like terms. So I only multiplied the 3. Actually, I didn't multiply 3 in anything, okay? The 5s will multiply out to 5 times 5, and then I saw that's a pair, so I grabbed that out. It's 5 times 3 is equal to 15. Anybody have any? Oh, that's number 4. Sorry. Number 3, I only multiplied the 3's together, giving me 9 root 5. Okay. Number 5, you just simply multiply the square root of 5's together, and then I multiplied the 3's together. So the 9 stays outside. 5 times 5, I pulled that out, and I got 45. Does anybody have any questions on that? Oh, I have to wear my headphones. I'm sorry. Okay, number 6. Raise your hand if you had trouble on number 6. Be honest. Don't be like, this is simple, okay? All right, let's see what you guys get. Let's see what answers you guys got. Who here is confident in their answer? Whoa. All right, how about who's confident in number 7? Woo-hoo-hoo! Much lower, isn't it? Okay. I know some of you guys are being modest. Like, well, I know I have the right answer, but I'm not gonna say anything. Okay, I'm not gonna put myself out there like that. Okay, all right. Help me out, guys. I have some conversion rates: 1 meter to 3.28 feet. I also have 1 foot to 12 inches. Okay, how do I set this up? What's the first thing I need to write down for number 6? I don't know where to start. 200 what? Inches. And we're trying to get that to what type of unit? Meter. And we could, I mean, some of you guys have done it different ways, but I like doing it this way because if you don't know how to do it this way that I'm about to show you, it makes number 7 a lot more difficult. Okay, so I think Katrina, honestly, has worked really hard to get this method down. I think she's got it locked in. So, if you guys need help from a peer, Master Katrina's right there. Okay, so 200 inches, and my strategy here is to get rid of inches. I'm going to delete the inches. I need to make this into a different unit to get closer to meters. There's no one conversion rate that goes from inches to meters. But what do we know about inches? Like how many inches are in something? Yeah. Okay, so if I know that there's 12 inches in a foot, I could write that as a fraction, right? 1 foot over 12 inches, or 12 inches over 1 foot. I'm going to multiply this number to one of these fractions. Which fraction am I going to choose to multiply by? The first one. Why? Okay, very good. So if I multiply it to 1 foot over 12 inches, I understand that if I multiply this in the same way that 4 times 1 over 4, if you do that, you know that because this is sort of like a numerator number and this is a denominator number and they're the same thing, they kind of cancel out. Well, the same thing can happen to your units. Inches will cancel out. And now we're left with feet. However, is that our final answer? No. Ooh, you're brand new to the class. You're like, no. I know where this is going. No. Okay, so where do we go from here then? Do we know any conversion rates between feet and meters? Maybe not on the top of our heads, but with a little assistance, do you guys see a conversion rate that we might be able to use? 3.28. I see you, Natalie. You're like, I'm not going to say anything. Okay, all right. So it's 3.28 meters over 1 foot. Oh, wait. Did I write that wrong? Well, how should I have written that? That was actually not intentional either. Okay. Mr. Wee, sorry. All right, 3.28 feet go on the bottom, and then 1 meter goes on the top. I can't make these numbers up. They have to be real, okay? They have to be realistic numbers. The feet will cancel out. And if you're, okay, so meters is good. My final answer is going to be in meters. If you don't know how to multiply this out, I'm going to use a handy-dandy tool here. Now, you guys can't do this yet. You guys don't know how to do this yet. But this is what the TI-83 is going to look like. Okay. Oh, look at that. Okay. I'm going to clear that. And you're going to do this. You're going to do 200. Okay. And you're going to multiply straight across. 200 times 1 times 1. Okay. And some of you guys might be like, well, I already kind of know what times 1 is going to be equal to. But you know what? I like to go every step. Okay. So 200 times 1 times 1. And then we're going to divide it by the numbers on the bottom. Divided by 12. And then again, divided by 3.28. And this should give me my final answer. Don't be uncomfortable doing that. You can totally do that. Did anybody get 5.081? Whoa, not bad. Okay, 5.081. My ultimate question now, which one's bigger? 200 inches or 5.081 inches? Or, I'm sorry, 200 inches or 5.081? They're equal. Okay, you did not change the value. Okay, we just look at it a little bit differently. Okay, so if you say to an English person or someone from Europe, oh man, that's 200 inches, someone would be like, I have no perception of what you're talking about. But if you say, oh, that's like 5 meters. Oh, I see now. I get it. All right. Yes, Katrina. Yeah, you can do that. Yeah, you can totally. 5.1 meters. Okay. 5.1 meters is good. If you're in chemistry, however, I'll be a little bit more strict about how those units look. But you're not in chemistry yet. Okay. That's why I'm telling you to skip number 8 on your dimensional analysis worksheet. Okay. Number 7. Okay. I think, let me see what your final answer. Did anybody get 30 miles per hour? Ooh, 30 miles per hour. Okay, so for you lucky few, not lucky few, but those that have earned their right to help me, okay, you guys can always help me. Can you guys help me? I have no idea what to do. I'll start with what I know. I got to start with 528 inches per second, and I need to get to miles per hour. Don't be scared of that, guys. Okay, What do I need to do now? What can I do now? Yes. 1 foot over 12 inches. Why are you choosing to do 1 foot over 12 inches? But how come there's no seconds or anything in here? Like, okay, so you don't need to do everything right all at once. Don't be scared that there's 2 units. You just need to kind of like cancel out each unit one by one. Right now we're focusing on inches to get to miles, okay? So we're going to do a plan of attack by going to inches, to feet, and then what's the next step? Katrina.
1 mile over 5,280 feet.
Okay. If we do it in this way, not 5,280 feet in the top, or else we won't be able to cancel these units. So it does matter the order, okay? Now we have our answer in miles so far. That's good. But are we finished yet? Not quite, because we have seconds on the bottom. And we don't want seconds, we want hours on the bottom. How do you suppose we get rid of those seconds now? Yes. Yeah, first turn it to minutes, right? Because I don't know how many seconds are in an hour. So, well, how's that going to look, though? Okay, and the seconds will cancel out. Look at that. Since the seconds are on the bottom, it's kind of like reverse thinking. You just got to put the seconds on the top now to cancel out the seconds, okay? Or the unit, okay? How about now? Ooh, look at that. 60 minutes over an hour. If I have minutes on the top now, I know that the minutes down here that were resultant are going to be gone now. And now, is my answer going to be in miles per hour? Yes, it is. Okay, so again, with my handy-dandy calculator, I'm going to multiply this across. 528 times 1 times 1 times 60 times 60. It's a bit of a pain here. Times 1 times 60. I feel like a little old grandma right now trying to do math. Times 60, son. Okay. Divided by, there's no number there. What do I do? Okay, we'll just put 1 there. Okay. Divided by 1. Okay. Divided by, oh dear. Okay. Oh, nope. I'm fumbling all over the place. Okay, divided by 12. Divided by 5,280. Okay. Now, for my old eyes, I don't know what's going on anymore. I'm like, what's happening? Okay, so divided by 1, and then divided by 1. All right. Now I'm officially gone seeing that. I don't know what's there. Ah! Ha-ha! Is it 30? Yes, it is. Okay, right. So your final answer is going to be 30 miles per hour. So please write that down as a note if you haven't, okay? If you need it. If you feel like you've kind of gotten comfortable with it, you don't need it. But for those that are like, oh, I don't really got this technique down, okay? This is a good time to kind of write this down, right? Okay, so I'm going to make this bigger, and then still, I know some of you guys are very comfortable, like, haha, I don't have to write anything down. I'm good. I'm going to start on notes now, officially, okay? So those were sort of warm-up notes for what you should know up to this point now. Then we're going to go into some new stuff today, okay? Whatever I can't cover by the end of the day, I will make a continuation video, like a part 2, okay? That means it's not optional to watch. You got to watch it, okay? Just think of it as like the lecture should have gone longer, but we just don't have that much time in class, okay? So find time this week to watch part 2 in case I have to make part 2. Does that make sense? Okay. Or else you won't know what's going to be on the test, or if you're that confident, it's like, I don't even know what he's saying, so I just go on the test blind. Then you can do that too. All right. Everybody got this down? Okay. Write this. Oh, okay. Right. Okay. Write this part here. This is just for you to know. So when I throw around some language, you understand what that means. If you can't read any of this stuff, so I guess the things that you need to write are this. So let me see. Just hold on. All right. Okay, hold on. All right, hold on. Okay, I know it's a little messy, guys. Okay. I need one of those worksheets. Yeah. Yeah, like T is for turtle, right? Okay, I know you guys can't see it. Let me help you out. That's 1-1 that's missing and cut up on the top right there. This is 1-1 here. This is adding and subtracting polynomials. Don't worry about the post-its. Those are notes to myself, okay? And then this next part says monomial. 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 Next one is binomial. Binomial. Next one is trinomial. Okay, I'm saying trinomial. Yes, yes. I was just trying to throw you off there, right? But that's trinomial. The next one, binomial or monomial, binomial, and trinomial. Okay, and hopefully everyone sees that that's not an S, but that is a 5. Okay. Imagine the amazement of my teachers in the past when they couldn't see the difference between my alphabet and my numbers, right? They're like, what is wrong with this child? Yeah, okay, well, all right, fine. Fair enough, fair enough. He still needs to learn how to write, which is okay. I understand. Okay, so next to the monomial is a 5x. Next to binomial is 2x squared plus 7. Next to trinomial is x cubed minus 10x plus 1. Is anybody understanding this weird pattern in the naming convention and the numbers next to it? Why is it that there's 5x and then yeah, what do you have, miss?
Maybe because mon means 1 by, obviously. Bicycle means 2.
Uh-huh.
3 tries 3.
Yeah, okay, right. I love the analogies you made. Everybody, I think, can totally understand what you're saying. Bicycle means 2 wheels. Tricycle means 3. Okay, that's a great way to explain this concept. It just means that the monomial only has one term. So one like term, 5x by itself. Okay, that's a type of expression. It's an expression, okay, with only one term. A binomial is an expression with two terms that cannot be combined. Does that make sense? Because can you actually add 2x squared plus 7, like meld them together into one number? You cannot, okay? So they're two distinct numbers. Trinomial, in effect, has 3 terms that are non-alike. And let me unfreeze this. So underneath this, I said, I know it looks really confusing, but let me highlight this in pink, maybe. Only these two are considered polynomials. Polynomials. Why poly? Why are both of these? Why are the binomial and the trinomial considered polynomials? Yes, Ivory. Yeah, poly just means more than one generically. So that could either be a binomial or a trinomial. Most people, though, or most mathematicians would say when you're saying polynomial, and the first thing in their head, a polynomial has 3 terms. They're just used to seeing it like that, okay? But technically a binomial is a polynomial as well. The other thing that we're going to learn about is the degree of polynomial. Sorry, I just totally messed up that spelling there. Okay, my senility is getting to me, right? The degree of polynomial is the greatest degree of any term in the polynomial. So in this case, x to the third minus 10x plus 1, without even looking, what degree polynomial would that be? Try or yes? Third. So it's a trinomial. That is a third degree polynomial. Whoa, we're getting really complex here, right? But once you kind of got down this language, which isn't too bad, okay, you can throw it around your parents. But I learned about polynomials today, in which degree they're in. They're like, yeah, I totally understand what you're saying. Okay, they're lying. They don't, right? No, not a lot of people remember this stuff. So you can go around flaunting how smart you are in the house, right? But don't do that, though. Your parents will quickly shut you down quick. Be like, oh, yeah, well, do you have a job? I'm like, no, not yet, Mom and Dad.
I actually do.
Oh, do you?
Yeah, with my mom.
Oh, nice. Oh, dang.
With dogs.
You guys are working? Oh, you work with dogs. Right. That's awesome.
Dog walking, dog sitting.
Yeah, I can't do any of those things because technically I have like allergies. So to me, that's like the hardest job in the world if you think about it, right? Yeah. Huh?
I kind of do accounting.
Yeah.
Not legally.
I'm not gonna take away from the fact that being a student is actually really tough. Like I would never go back to my college days. That was the last school I've had. Like I am tired of studying for tests and stuff like that. So you guys have no idea how comfortable I am to be like, here are your tests, because I know what you're going through, and now you probably don't know what I'm going through. I'm like, oh man, I'm sorry for you, you know. Like I feel bad for you guys because I'm like, I know how that feels. It's like I just want to get through this day. This really stinks. Okay. So I remember what that felt like. Okay, so I'm not going to go into too much detail. Anything to the second degree, if your highest term, meaning like the highest power that you see next to a variable, whatever it is, that determines what degree polynomial you have. So if I had a 5th degree polynomial, what is the highest exponent I'm going to see in that polynomial? Yes. Yeah, so if I had, even if it was just x to the 5th power plus 1, that is still technically a 5th degree. You don't have to write this. 5th degree polynomial, okay? Capiche? Everybody got that? Okay, so I'm not going to be tossing around degrees a lot. I just wanted to teach you what that means. But I am going to be tossing around binomial, trinomial, and polynomial. Those are the 3 terms you probably want to get locked in your brain for good, okay? All right. Without further ado, I keep saying that, okay? Let's begin some work on 1-1. I'm going to write in a more legible pen. 1-1. Adding and subtracting. Oh, so you guys can just continue where you left off, okay? So you don't have to retitle it, okay? You guys should already have that at the top. Adding, subtracting polys. I'm gonna shorten that a little bit, okay? Polys. Okay, hopefully I'll write a little bit better. All right, so here's a sample problem that you might need to know. A sample problem. This type of problem is called subtracting polynomials. Subtracting polynomials. And your first example is going to be this. 3 minus 2x plus 2x squared minus 4x minus 5 plus 3x squared. So here's my strategy. I'm going to give you like 2 or 3 sample problems, and then after that, I'm going to give you 2 problems to do on your own with a partner, okay? So we're going to go through like 2 things of notes, at least. Anybody have any suggestions for what I should do? Yeah, Hassan? I'm sorry, not Hassan. I'm sorry. Fayad.
Because there's a negative, you should first multiply it by the parentheses multiplying. So you should do before you do anything, this do the 3 minus 2x plus 2x squared plus or just minus 4x plus 5 minus 3x squared.
I see where you're going with this. I'll help you out here to clarify some of that for the other students here. What is this property called? Distributive property. So let's distribute that negative sign first to each of these 3 numbers in this parentheses. 3 minus 2x plus 2x squared minus 4x. That minus and that negative 5 will make that a positive 5. Okay, plus or minus 3x squared. So now that minus gets distributed to 3x squared, and we have this. Now, this step, we just combine like terms. So let's see what things I can combine. The 3 I can only combine with a 5, so that's 8. 2x can combine with who else? That minus 4x. Oh, technically that's, yeah, thank you. That's minus 6x, and then 2x and negative 3x. Uh-oh, what is that going to result in? Yeah, negative 1x squared. In your book, you won't see the 1 necessarily, so it would be the same thing as just saying minus x squared, okay? What degree polynomial is that? 2nd degree. Okay, very good. Let's go through one more sample problem, and then I'm going to give you some problems to do on your own. Okay, sample problem. Here's another sample problem. Okay, this is simply simplifying expressions. Okay, simplifying. I can't say it. Simplifying. Okay, simplifying expressions. Simplifying. Simplifying. Okay. All right, here's your sample. You're going to evaluate this expression. 15t times 10y cubed t to the 5th power plus 5y squared t. Beat that, kids. Right? Okay. And minus, 2y, yeah, just 2y, I think. Yeah, 2y. That's what I want. yt squared, okay, plus 4y squared. Oh, I bet you guys are all quivering right now, aren't you? 10y cubed t to the 5th power. Charlie, was that a scoff I see? I'm not scared. Not of you. Okay. I was just kidding, Charlie. I just saw your reaction for a second, and I just kind of went with it. It looked like you were not amazed by my problem here. Okay. This looks really intimidating. We're going to use the distributive property for both of these. But the question is, how is that going to look? Any guesses to what the first term is going to look like when I multiply 15t times 10y cubed t to the 5th power. Who can do that in their head? That's pretty tough. Jacob, did you? Yeah, you lit up a little bit. This is pretty tough, isn't it? Any guesses? Ivory, do you want to take a guess?
150 ty cubed t to the 6th power.
Okay, so
Or wait, not ty. Just
there you go.
150 y cubed t to the 6th.
Okay, first of all, how did you get 150?
15 times 10.
How come you didn't multiply that 15 to anything else? Well, actually, are you technically multiplying 15 to everything else? You kind of are, but the numbers that are alike are 15 and 10. So those are going to be multiplied together, right? What about the y cubed? Does that change? No, the y cubed is still going to be y cubed, but the t's, however, being multiplied will become t to the 6th power, okay? Plus 15 times 5, which is, I think, 75. T goes to the t in here, so there's 2 t's. So what power is that t going to be at? 2nd power. Okay, very good. I'm gonna draw. You don't have to color code it like I do. I just want you to kind of make sense of my notes here. And then I'm gonna. Oh, I got the next one. Ty times yt squared. I think I got it. It's just gonna be plus 2y squared, right, Mr. Wee? The y's are multiplied together, and the t squared. Why is that a hard no? Yeah, Tessa. Oh, so kind of this whole thing is being distributed, right, Tessa? Whoops. Whoops. I'm the math teacher here. Whoops. I totally made a mistake. Okay, what about the next one, Tessa? What is that going to look like? Okay, so that negative 2y times that positive 4y squared, the 4 and the 2 are going to multiply, and then the y's are going to multiply together. That's y to the 1st power times y to the 2nd power. That's y cubed, okay? And then, is there anything like terms in here? Be careful. Do any of these two look alike? Yes, these two look oddly familiar because they have y squared and t squared and y squared and t squared in here. So you can actually combine them. 75 of these guys minus 2 of these bad boys, bad persons, sorry, right? Got to be more inclusive these days. Got to be very nice, right? 150 y cubed t squared plus 73 y squared t squared minus 8y cubed. Okay, now here's an opportunity for you guys to kind of catch up in case you got lost in the midst of this. Work with someone that looks like they know what they're doing, okay? And then learn from them, right? That's why I want you guys to partner up. It's not just to partner up with your best friend and kind of get lost in the muddle together. That's fun too, but try to learn from each other too. Okay, here are your sample problems. We got a problem. We got a problem. Okay, there's your first problem. So get up on your little toes, okay? And find a whiteboard space. Erase it, all right? What's your name again, miss? With the red shirt? Petunia. Okay, follow Petunia's model. Please erase whatever's on the board so you have your own space to do this. Okay, there are your 2 sample problems. Woo-doo! Woo-doo! Here you go, Brendan. My friend. What time is it? Katrina and Natalie, watch out. I'm going to pull this back so that way it's not like directly behind you so you can trip over it, okay? There you are. P cubed. Yes.
Why do we distribute the minus into the
The
equation? Why don't we just leave it?
oh, like that. If you have a parentheses, do you remember the order of operations?
Yes.
Okay, what's the first letter in the order of operations? Parentheses.
But I thought that meant you do all the parentheses.
Yes. So that means, well, everything that's been done on the inside has been done, but anything on the outside the parentheses is your next step. So if you have a minus sign or you have a number in front of it, then you have to distribute it to the like anything within that parentheses.
Alright, so it's parentheses and then exponents.
Yes.
So exponents is like
No, so don't worry about you. You're not doing anything with the exponents right now. So all it means, order of operations, is whatever's in the parentheses. Now you got to distribute whatever's right outside of it into the parentheses. Then there's no exponents. There's no multiplication, I don't think. And then there's, let's see, pem to everybody.
I know, but is it like that?
Think of it this way: it goes in the front of those terms. So right in front of the whole 3p squared, it's gonna go in front of the 3.
So is this correct?
No, see, I don't know if is this like separate from this.
That's correct. Yes, they are separate. Because you see the I'm gonna point this out. You see the signs in between, the plus and the minus. It separates those numbers together. When they're written close together, like this. Do you see this now? How many distinct terms do you see here? Like different terms do you see? Hard to see, right? How about this one? How many can you see now? 4. It was very easy for you to see 4, right? Because they were separated by what? Symbols, right? Is this separated by any symbols? So that means they're all together. Okay, right? So that's how you can tell. 3p squared, if there's no separation between those guys, they're all the same guy. Okay? 3p and 2. What? How? Okay, 4p cubed. Maybe? Okay, and then 3p squared.
Yeah, it's 4p and then minus 3p.
Okay, you're finished. Go ahead and have a seat. Otherwise, don't worry. Take your time.
Wait, but this is 16. So what do we add all these p's together?
16p plus
Wait, no, why 16p?
no 9
9 and 7.
16.
I might just show off at 210. Hey guys,
May I ask you guys, on the first question, how many terms separated did you guys come up with? Like, as in, let me see, like, over here, let me laser point this, so everybody pay attention to this here. Whoa! Don't get in front of the laser, all right? You'll get cut off in half. Right? I've seen it happen, okay? These two here, that's 1 term and that's 2 term.
Okay.
Your answer, how many terms, right, with your fingers, whatever it is, show me how many terms you have in your first answer. I got 4, got a few 3s, got a few 3s, got a few 4s. Okay. You guys ready to see my answer? Double check yours. Whoops, that's the same thing. Okay, in green is my answer. Please check.
Oh, no, we're not wrong yet. I really thought we were wrong.
This was tricky. I always make this mistake. My initial answer always has 3 terms, but I always make that mistake. Why is it that this is 4 terms? What do you think is the most common mistake here? Yes.
Because there's a cubed and a squared, and some people would probably just together.
Yeah, so this right here, 4p cubed, cannot actually combine with this because this is 4p squared. Oh no! No! It's okay. She means well. don't attack her. Yes. How could you? I know what you're saying though. But yeah, you have the full capability to get this right. You just made a slight mistake. That's all. Okay, you guys ready for the answer for the second one? Yeah. So Nah, yeah, mixed messages. It is negative 8p cubed minus 100. Did anybody want me to go over that? No? No. Katrina? Okay, yes, okay. Hey! I love that she asked me. I love it because she's just like, hey, guys, back it up. Because some of you guys are like, yeah, don't. But in your head, you're like, please, someone else. I don't want to be the one to ask, okay? So thank you, Katrina, right? Sticking your neck out there for us, okay? Oh, I would have, yeah. Hey, younger version of me would have totally thank you. Someone took it, right? Someone took criticism for that. Okay, so 2p negative 4p squared. Okay, so you guys can help me out, right? Because I know you guys kind of get tired of my voice here. So help me out here. What do I do? So just no hands raised. Just say out loud. What's the first thing I do? To who? First set of parentheses, okay, and then and someone else said that this number and this number. So I got. Oh, it'd be p cubed. P times. Okay, good. Now what? 10p. That's it. Oh, okay. Sorry, because there's two p's. All right, sorry guys. Oh, both of them. Okay. So it's minus 5 times 2. Okay, 10p squared. Thank you guys. Oh, minus 100? Why? Oh, okay. All right. Thank you. Well, I don't know. Okay. Just give me a break, guys. Okay. Okay. Is it all right? That's. Well, oh, that's right. This is positive. This is negative. Very nice. Okay. Good. Thank you guys so much. You guys totally helped me out here. Thank you. All right, guys. Round of applause for yourselves. That was very good. Okay. Very good. Okay. Let's blaze new trails with this next one here. So this is a little bit of review for a lot of you guys for this next one. I think a lot of this might be already reviewed for some of you guys. Maybe not. So whatever it is, I'm happy you guys are in this class together, right? So we could help each other out. So we're on section 1-3, multiplying polynomials. You can start a new paper or you continue on your current paper, however you like to set up your notes. This is how you're building your college note style, okay? By the time you get to college, and the teacher just goes, you will have a way to write notes. You could do that, but that stinks because when you go back home, you have to watch the whole thing or listen to the whole thing. Someone's a lot smarter than other people about how they took notes in college, okay? Because I didn't know. I was like, guys, did you guys have any notes? Did you guys take any notes? I fell asleep the whole time. Okay, so the first one is we're going to be multiplying binomials. I think binomials. What is that going to look like? Kind of before I even just go into this, so you guys are just like multiplying binomials. All right, let me just write down this note. Really think about critically. So first, it keeps you awake, and two, it actually keeps you engaged in the content here. What would that even look like? Multiplying binomials. Have you ever seen that yet? Whoa. Okay. What? Can you give me an example of multiplying binomials? What that could possibly look like? Is it something new to you that you've seen? Have we done it today? Have we done multiplying binomials? We have. Look back in your older work. What would be like an example of multiplying binomials? Like all the way back to the beginning of class, let's say. What would be, yeah. Which would be, can you give me number 2 in the warm-up? Uh-huh. Okay, where are the binomials, guys? Where do you guys see binomials? Yeah, Ivory? Yeah, that's right. X plus 4 is a binomial and X plus 3 is a binomial. Nothing different, right? Okay, does anybody remember how I took care of this problem? Yeah, Tessa. Okay. That was it. So the first part and the main takeaway from this, what is it? So this is x squared plus 3x plus 4x plus what is it? 7? No, 12. 12. Thank you, guys. Just the main takeaway from this is get this down. Okay, get this skill down. If you don't know it by now, right? That's definitely a big important thing that I need you to know from 1.3. I'm going to be tossing that around a lot at a very quick pace. Okay. Whoa! But the next one, though. Oh, this is going to be endearing. Okay. This is going to be cute to some. Okay. Multiplying polynomials. So if you can imagine that these were binomials, what the heck is multiplying polynomials going to look like? Wait a minute. Are these technically different? Yeah. Why would you say they're not different? Yeah, it is. Okay, so I do apologize. Sometimes your book does this. They try to make it distinct, like binomials and polynomials are different, but they're not. But in this case, I'm going to treat it slightly different visually. Okay, like when I say polynomials, try to think of more than just two terms. Okay, so in this class, I know a binomial is a polynomial, but I'm not going to try to trick question you. Okay, when I mention polynomials, I'm thinking of a little bit more in two terms. Okay. So give me 1 second. I'm going to turn on the AC. Does anybody want the AC on or no? No? No, you guys are... Yeah? How about like 1 degree? Yeah. Okay. 5 degrees. Yes. No, 20. 20, no.
Yes.
That's inhumane. Okay, I went 2 degrees lower.
Yeah, alright. That's a good call.
All right. So here is one. Here's a sample problem. Is anybody scared yet? I like you guys. No. That was a hesitant no. I don't think so. Okay. Do not be frightened. Those that want to venture forward and be bold, would anybody like to give it a try about what would the first step look like? What may the first step look like? Yes. Ooh, that's it. And then that was a very, very nice, bold step forward. Okay. Anybody guess of the next step? Yes. That's it. Is that so tough? No, it's like the exact same thing that we've learned before, just applied to a few more terms. So I'm going to write everything in green that's being multiplied. So 6x times 2x squared is going to be 12x cubed. 6x times minus 3x is going to be, 18x squared. That's always a common mistake, so catch yourself there. There are two x's, so don't just think that they're being added together. They're being multiplied, so that means it's x squared. 6x times minus 5 is minus 30x. Don't forget that. And then in pink, in here, I'm going to add these new terms. 5 times 2x squared is 10x squared. 5 times minus 3x is going to be minus 15x. And 5 times negative 5 is minus 25. Please check my work to see if there's anything wrong. How about this? Incentive. If you actually do legitimately catch a real mistake that I've made, I will give you an extra credit point in this class. Okay? Because it keeps you on your toes, hopefully. Like, all right, I'm in this. Okay? So this is 12x cubed. See, combined like terms. So I see x squared and 10x. 18x squared and 10x squared are like terms. So I'm going to combine these two to make minus 8x squared. Minus 30x minus 15x. These only have x's to the first power, so those are like terms. So I'm going to add them together. Give me minus 45x and then minus 25. That is my final answer. Yes? Good? Are we good? Okay, special products and factoring using distributive property. Okay, so let's get on our toes again. No? You don't want to be on your toes for this one? No? Okay, how about we mix it up? We stay. Oh, Ruby was ready though. She's like, yeah, let's go. Okay, I'll give you the choice. Okay, sometimes I will order you and command you to go on the boards, but let's kind of like take a break from that. Okay, if you like to go on the board, you may. Okay, or if you like to stay at your desk and work on a piece of paper, but you may. Okay, I'm gonna give you 2 sample problems. You get to work on, but at least work with a partner. Okay, at least discuss your answers with a partner. That's the very least I ask for. Okay, I'm gonna give you 2 problems. Uh-oh. Mr. Wee's upped the ante a little bit. Yeah, go ahead. Okay, so you have 18x squared. Oh, I think you missed something. That's why. 5x squared. Where did you get that? You got that from. Oh, this here. 5 times 2x squared. The 5 and the 2 can be multiplied together. You wrote 5x squared. That's why. And that's where the minus 8x squared.
Okay, so it'll be 10x squared.
And then 10x squared can be combined with negative 8. You got this. Killing it. If you need help, go around and ask your friends. Otherwise, come and ask me. I will come and help you.
Okay, next problem. Take a parenthesis squared plus 3y minus 1. 3y squared minus 5y.
Malvin, what time are you guys gonna go? I keep forgetting. 10:35. Okay. So that gives me about 10 more minutes, I guess. No, 15. No, 15. 10. Malvin! 10 more minutes. Malvin! Yeah.
question.
Do not worry. How can I help
Okay, so for the I'm still working. But how do I can I combine this? So I did 21x minus 24x minus 35x.
you? Yeah. So let's see. Is that what is the next one? Oh, let me see. Yeah, I want to see what if I get the same thing as you. Good. And then you got plus 40 at the last one.
Yeah.
Okay. Now you're gonna combine what?
21x minus 24x minus 35x.
Oh, you got 21x. Be careful. It's 3x times 7x. 21x squared. So yeah. So what are we gonna combine?
Okay, so now I can only do negative 24.
Oh, 24. Yeah.
X squared.
Oh, no, that's not squared because look at how you got 24. You got 24 from 24x from 3x and negative 8. So that's just 24. So 24x can combine with. Let's do that together because I don't know because I'm solving at the same time you are. 24. Even though they're minusing, they're subtracting. I'm gonna add them together. So 24 plus 35 is 59. Do you get that?
Yeah, I know why.
So 35 and 24 is what we do.
Yeah, so that's minus 59.
Yeah, minus 59x plus 40. And that's it. That's your final answer.
That's because I don't know if you
No, you can't. X cubed is by itself. So you should have like 4 times. Yes.
Hi, I was wondering if you'd still like me to do all the previous lines, to catch up.
Let's
or
not do that. But I would still suggest going through
Looking
my
over
notes.
them? Yeah.
Looking over them because that's still going to be on the exam.
Okay.
So you have the option to go back. I would still suggest maybe going back and doing a few problems just to
Right,
practice
yeah.
for the exam.
Okay. Okay, but which line should I start on for homework?
What we're starting on today, 1-1. Okay.
Okay.
Let's do that. It works. Wait. Start on lines 5 and 6.
Okay.
That you need to start. Okay, yes.
Did you want us to do number 8?
No. Just keep
I
it.
didn't say I was like so confused.
All right.